Alright guys, here's a video for 3.3 to help you with your homework, writing equations of polynomial functions. And I'm going to try, if the time allows, to do these problems 1, 2, 3, 4, 6, and 11. Okay? So let's go straight to your packet and just check to see if you did those right, if you did them correctly, and if not, let's go ahead and fix them and make sure we do them right. So let's go ahead here to number 1. It says, in class we talk about the difference between writing an equation versus writing the equation. And let me just remind you here in my notes, in case you were absent, write an equation versus the equation. So versus the equation. So in an equation, we don't need to solve for the stretch, which is the letter A that we use in the function. And in the equation, we need to solve for the stretch, which is that letter A. We use the variable A in the function. So the function is always written f of x equals the stretch A times, and then we use the y-intercepts, okay? The factors, the rest of the factors in the function. Usually is x minus dot dot dot, whatever, how many factors we have there. So in an equation, we don't need to solve for this part because we just want a general equation, but the x-intercepts must be correct. So we are not worried about the stretch on an equation. But the equation, or its equation, we do want to know A. So f of x equals, we want to know the function, we want to know the stretch, and the x-intercepts, the factors of the function, how many factors are there, we want to know. And we do want to know the specific stretch for that specific function. In an equation, we want the x-intercepts, which are the factors, but we are not precisely identifying the stretch of that function. Okay, so that is the main difference. So you will see in the examples I do here in the worksheet. So take a look over here. Number 1 says, for 1 and 2, write an equation for the polynomial graph above, shown here. So I know the general form. I'm going to write it up here, is f of x equals the stretch times x minus certain value times x minus certain value. Those are the roots, root 1, root 2. And it could have many factors. It could have 3, 4, 5 factors. We don't know. Okay, root, that would be the first root. This would be the second root. We don't know how many factors there are. So I know now, looking at a graph, exactly how many roots there are based on what I see here, and I can create that. So following this general form of a function, I would write f of x equals A. Because it's an equation, I don't need to solve for A. Then I would take care of the roots. X minus the first root I see is a -3. So if I do a -3 in here, this negative times this negative would become positive. But I'm not going to do that yet. I want you to see it. I just insert a -3 in here. Okay? Because it bounces on -3, it bounces right here on -3, I'm going to put a squared because that's what we learned about multiplicity. And then my next root would be x minus a -1. So let me put a -1 here in parentheses. It crossed it. So it crossed here, but it bounced here. The bounce get the squared. The cross just went through it, so we don't put the square. And my next root I see here is x minus a +1. So there we go. Now if we clean this up to make it look nicer, we would have that the function is f of x equals A, x, a negative minus a negative here and a negative here, it's multiplying, is a +3 squared, and x minus a -1 would be a +1 here, and then x minus a 1. So that's what we would see here. If you want to clean up even further, you would see that this over here is a difference of squares. If you want to combine it, FOIL it, combine it, you would be able to clean this up even better. We know that A must be positive because it's an increasing quartic here. It's an increasing polynomial. So I know that A is a positive value. You can also mention that, okay? So here is an equation. Let's take care of this other one as well, following exactly the same pattern. We look for the roots or the x-intercepts of the function. We have the general form and we follow exactly that same form all the time. So f of x equals a. We know a must be negative because it's coming from a positive infinity and it's coming decreasing function. So I know a is going to be negative, and if I want to mention that at the end, I may say a is less than 0. Okay? Here we know that a is greater than 0, a is greater than 0, because I know our function is increasing. Okay, so here we're going to have a. Now let's take care of our roots. X minus. The very first thing I see is a negative 2, which it becomes a positive 2 here. It crossed, and because it crossed, does not get a square. Then I crossed again at 0. So x minus 0. And then I crossed again at 3. So x minus a positive 3 is right there. There we go. So now I can just clean up a little bit more and make it look better, nicer. X minus 0 is just x. And since x is alone, I'm going to write it in the front. So I'm going to move up over here that there's more room. My function would be f of x equals the stretch a, and then we have this x minus 0, which is just x, and then the x plus 2, and then the x minus 3. So here are all the roots. If I solve this factor, we are kind of like working backwards in our minds, back and forth. If I would set this factor equal to 0, I would get that x equals 3. There it is. If I set this factor equal to 0, x plus 2 equals 0, and solve for x, I would get that x equals negative 2. Right there, we crossed it. And if I set an x equal to 0, we would get that right there, it crossed it. And a is a negative value, is less than 0, because this function is decreasing. So there we go. You just need to pay attention to the x-intercepts, look for crosses or bounces, okay? Let's do one more. Let's do number 3 to make sure we did it right. Now number 3 is not asking for an equation, it's asking for the equation. Now I really need to solve for that a value that we didn't solve in the beginning. Okay? So over here, let's take care of the roots first. Let's take care of the x-intercepts. So it looks like I'm crossing at 0. I'm going to put a little c to say I'm crossing at 0. Looks like I'm crossing at 1, and looks like I'm crossing at 2. So none of these has multiplicity of 2. They have multiplicity of 1 because we're just crossing. So none of them get a squared. It's not a squared term. So it's going to be f of x equals a times my very first root is 0, minus 0. My next root is x minus a positive 1. So let me write a positive 1 there. And x minus a positive 2, and there's my positive 2 right there. It says minus a positive 2, minus a positive 1, and minus a 0. None of them get a squared exponent here because none of them are bouncing. Now, that is an equation. They're asking me for the equation. I notice that there's an extra point over here. I can use it. X is negative 1, y is negative 12. I can use it in my function and only leave a as a variable and solve for a. So I would plug in negative 12 for y, so f of x is y, so negative 12 equals a is what I'm trying to solve, and instead of x's, I'm going to write negative 1. So negative 1 minus a 0 is negative 1, and then instead of an x, I would write a negative 1 minus a negative 1 would be a negative 2, and x instead of x is a negative 1, and negative 1 minus a 2 is negative 3. Okay? So all I came over here and I replaced every single x for the negative 1, and I just did it in my head. Negative 1 minus 0 is negative 1. Negative 1 minus negative 1 is negative 2, and negative 1 minus negative 2 is negative 3. Now I just need to multiply all this out and then divide it so I can isolate for a. So negative 12 equals a times negative 1 times negative 2 is positive 2, times the negative 3 is negative 6. And then I'll divide both sides by negative 6 because I'm trying to isolate for a. Divide both sides by negative 6, and we discover that a equals 2. So now I know what a is. Now I'm ready to rewrite my original function knowing what a is. So the answer would be f of x equals a is a 2, x minus 0 is just an x, and x minus 1, and x minus 2. So I like to double check my work. My leading coefficient is positive. That makes sense because I'm going from decreasing up to increasing. I have x times x times x, that is a cubed function, that is correct. And I am touching at 0 right there, at positive 1 right here, and at positive 2 right here. So I just double check my work, and here is the final equation, the equation for this specific graph. Right, let's do it one more time so you understand the difference between an equation and the equation. For number 4, let's go ahead and follow the pattern here. I'm going to start with f of x equals a, and I'm going to start looking for my roots. My first root, my second root, how many roots I have, okay? So it looks like I have a negative 1, so let me put a negative 1 here, and a negative times a negative 1 becomes a positive 1. We're bouncing here. There's a bounce, so that means you get a squared. Okay, the x plus 1 is a squared. And then my next one is a cross at positive 1. So let me put my positive 1 there. And then my next one is also a cross at 2. So x minus my second solution or root is a 2. So there we go. I only bounced a negative 1. So this is the only factor that gets squared. So there we go. We have the solutions. The x-intercepts are all taken care of. They're all good. I just need to solve for a. I'm going to come and use this extra information here on the graph, which happens to be 0 for x, negative 3 for y. I'm going to plug this in my equation, my function right here, and solve for the stretch, for the a. So negative 3 is the y value, so it goes right here for f of x. A stays alone. And everywhere that I see an x, I'm going to replace with a 0. 0 plus 1 is 1, but I must square that 1. And then 0 minus 1 is a negative 1. And 0 minus a 2 is negative 2. So I'm not writing it down, but all I'm doing is plugging a 0 for x. Okay, so now I have no x's and no y's. I replace the x's with 0, the y with a negative 3. Now I just need to calculate all this and then isolate for my a. So negative 3 equals a times 1 squared is 1, times a negative 1 would be a negative 1, and times a negative 2 would be a positive 2. Now I have negative 3a, negative 3 equals a times 2. To isolate the a, we would divide it by 2 here, and divide it by 2 here. So a would be a negative 3/2. There we go, we know a. Now we can write the final function. F of x equals negative 3/2 times, here back to all of the roots that we found here, all the factors, yes. So x plus 1 squared, x minus 1, and x minus 2. And here's your equation. Here's the function. And let's double check. We have a negative leading coefficient. It does make sense because our function is going to negative infinity, is a decreasing function. And we have, it's a quartic, so we do have x squared times another x and another x, so it's x to the 4th. And we have our bounce at negative 1, our cross at 1, and our cross at 2. So that's how you write an equation. Just have to put all this piece of information together. When you bounce, when you cross, how to solve for a, and pay attention to details. Let me do one more, and it would be the quartic function right here. A quartic means my highest degree would be a 4. A cubic over here says my highest degree is a 3, okay? So you just have to understand those is new vocabulary words, quartic and cubic. So I know I'm doing something that is a quartic function, something that looks like what we just done up here, okay? Let's find out the piece of information that was offered to us here. It says it touches -6, 0. So 1, 2, 3, 4, 5. -6 is right here. So here's -6. And then he also touched -2, 0, which would be right here, -2. And then he touches 0 for x, -20 for y. So 0, I'm going to put -20 very low over here. Touches over here. And then 4, 0. 1, 2, 3, 4. Touches right here on 4. And at 5, which is right next to it, 5. None of these intercepts are doubled, so none of them didn't show it twice. It just says touches here at -6 and -2, the y-intercept, and at 4 and at 5. I know it's quartic, and quartics either looks like this, pointing down or pointing up. So I just have to kind of like know how to connect this curves and make sure that it works out to look like one of the quartics we know. So it looks like if I cross this 2 right here, then I can touch the y-intercept. So it looks good to start. And then if I go back to these other 2 points over here and cross this 2 x-intercepts, then I finish my graph. Okay? Now they want us to write its equation. Well, I already have all the x-intercepts, so I can write those. I can write my factors. So f of x equals the stretch, which we'll figure out in just a second. Let's take care of all of our factors. X minus the very first root is a -6, so it's going to become a +6. X minus a -2 is going to become a +2. X minus my next root is a +4, so there we go. And x minus my next root is a 5, so there we go. So I took care of all of the factors. I know all of the roots according to my graph over here. Of course, there's an extra piece of information right here, which it happens to be the x is 0 and the y is -20. I am going to use that to solve for my stretch. So -20 is the y value, a times the x value is 0. So 0 plus 6 is 6. 0 plus 2 is 2. 0 minus 4 is -4. And 0 minus 5 is -5, -5. So if you solve for this, you get -20 equals a times 4 times 5 is -4 times -5 is +20 times 12, you have 240. All right, let me double check one more time. That is 10, 20, yeah, that's 240, okay? Positive 240. Then I just divide both sides by 240, just like we did here the other 2 times. Just to go back a little bit, see, at this point I divided both sides by 2 to isolate the a. Over here I divided both sides by -6 to isolate the a. The process, if you pay attention to details, is always the same, okay? So over here back, you divide it by 240, we get a all by itself, and I simplify this by zeros and by 2's, I get -1/12. So my a is -1/12. Now I can go back and rewrite the function with my a stretch being -1/12. If I have room, I'm going to try to squeeze it right here. F of x equals -1/12 times, and then I repeat all the factors. X plus 6, x plus 2, x minus 4, and x minus a 5. So there's my answer. I have all of the factors, and I know exactly what the stretch is for this specific function. So take care of the, my system or process here is always I take care of the factors first, and then I use the extra piece of information, is usually a y-intercept or another point on the graph, okay? So that's how you write the difference between the equation and an equation. So go ahead and finish your work. And did I promise to do one more? I did, but I'm out of time. I got to do another video So hopefully this will help you with the difference between the equation and an equation. Good luck.